Okay, it's time to solve a Charles law problem. So I wrote down Charles's law here along the top, and let's take a look at the problem and decode it a little bit. It says, what happens to the volume when a 350 milliliter soda can containing water vapor at 90 degrees Celsius is inverted, which means turned upside down. So this can is inverted into cold water at a temperature of 25 degrees Celsius. They want to know what happens to the can. Okay, well, this is a very famous demonstration that most chemistry teachers will do. You basically heat up a soda can on a hot plate and then you turn it upside down into some cold water. The cold water cools down the metal of the can, and it also cools down the gas that's inside. So let's assume that the 25 degrees Celsius is the final temperature of the gas, because everything that comes in contact with that cold water is going to cool down. All right, so this volume that we see here, this is our initial volume. The temperature here, this is our initial temperature. All right, so this is T1. The final temperature, T2, is 25 degrees Celsius, and they want us to find the new volume. All right, so a couple of points to keep in mind. First, whenever you're dealing with temperature, you have to remember that we need to use Kelvin. So you're going to take all the temperatures that are in degrees Celsius, you add 273, and that gives you the temperature in Kelvin. So for example, the 90 degrees Celsius that we start off with, we add 273, and that gives us a final temperature of 363 Kelvin. Okay, so this is going to be our initial temperature. Now the final temperature is going to be 25 degrees Celsius plus 273, and so if I type that in, plus 273 gives us 298 Kelvin. Now depending on your course, if you're taking honors or AP level, you may need to use more accurate numbers than 273. A lot of textbooks will write 273.15. Okay, if that's what your teacher expects you to use, then be sure to use that value. Okay, but I'm not going to go crazy. I'm just showing you how to use Charles' law. Okay, so now that we have our temperatures in the correct units, we're ready to set up the Charles' law. So as I do this, even though I've written the law up top, it's a good idea to copy it every time you solve a problem, because this will help you memorize slowly. It will help you memorize Charles's law without having to sit there and write this out a billion times, okay? You may need to practice a few problems, but that's okay. All right, so here's Charles' law. Let's sub in some numbers. So we have 350 milliliters, okay, is the first volume. Then we have our first temperature, which is 363 Kelvin, right? And then here we're looking for the volume. Okay, so we need to substitute in V2. We don't have a real number yet, but we will shortly. And then we're going to put in 298 Kelvin. Okay, so that is the setup for our problem. So in order to solve for V2, one way to solve the problem really easily is multiply both sides by 298. So I'm going to do that. And then this cancels with this. And so my final answer is whatever this result is. So let's use the calculator one more time. Times 350 divided by 363. And we get our final volume of 287.3. And of course, this is in milliliters. All right, so this is our final answer. So let's figure out the second part of the problem, which says, what happens to the can? Well, if you had a can that started off at 350 and then it changed to 287.3, basically what happens is the can is crushed by the atmospheric pressure, okay? Basically the can goes from a volume of 350 to a smaller volume of 287.3. And so the atmospheric pressure pushes on this can, right? And this is just a little representation of a can. The atmospheric pressure pushes on all sides of this can and basically turns it from a nice looking can into something that probably looks a little crimped, all right, like so. All right, so this is like your before picture, and this is the after picture, okay? You can always ask your teacher to demonstrate this in class. It's actually pretty cool, and it doesn't really require that much setup from the teacher. Okay, so that's all I have for you on Charles' Law. Enjoy, and remember, you need to practice until you get consistent, correct answers. So make sure that you're practicing and you're checking your answers to make sure that you got them right.